Hello, my name is Strathearn, and today I'm going to introduce. Hello, my name is Strathearn, and today I'm going to introduce our paper Task to Dial, a novel task and data set for common sense enhanced task-based dialogue grounded in documents, on behalf of myself and Dimitri Garcia. So, what is common sense? Common sense is our innate understanding of the world. It can be broadly categorized across different knowledge bases, such as spatial knowledge, which is distance and sequences, object properties, which are similar properties to determine the utility of objects, behavioral knowledge, which is cause and effect, i.e. fire burns, temporal knowledge, which is time and sequences, and contextual knowledge, which is our understanding of events and situations from previous experience. So how can AI benefit from common sense knowledge? Well, embedding common sense knowledge in dialogue builds a more robust and accurate representation of the real world for AI to generate from. And this is particularly important in things like task-based dialogue. So, for an example, if you can imagine a cooking recipe. Now, the structure of a cooking recipe is very formal and it uses very concise language. But in doing so, it also misses lots of common sense knowledge and natural conversation patterns. Now, common sense knowledge typically underpins dialogue rather than is explicitly embedded within it. So, if you can imagine in a cooking scenario, in a cooking recipe, it may say, take the pie out of the oven. Well, across all these different knowledge bases, we can see that we need more information than this. Maybe the fact that the pie is going to be hot could be an issue, which is behavioural knowledge. So how could we, what kind of common sense knowledge could we use to handle this situation? And one maybe to use another object like an oven glove, or to wait for the pie to cool down, which would be our temporal knowledge. So it's what we did to start with our project, is to really think about how common sense knowledge underlines dialogue, underlines a task, and extract these sequences, these scenarios, and use them in databases. So for our task, we created a database of cooking recipes, and what we wanted to do is we wanted to focus on a few key areas of common sense knowledge. So we wanted the ability to change objects for objects that may be missing in a scene. And this is something that's important in real world scenarios. So, for example, the user may not have all the ingredients for a recipe, but they may have suitable alternatives within their environment, within their kitchen, that they could use instead to be able to complete the task. Similarly, the user may not fully understand how to use all the objects within a kitchen, or where they are stored, or safe handling the utility of objects. And we also wanted to be able to explain that to the user in order to increase task success. And so what we did is we formatted our data set in an information giver, information follower format, which was loosely based on the give challenge. So in this scenario, the information giver, in this case the AI, might choose to omit irrelevant information and simplify the wording, or provide it to the user as is, depending on the needs of the user. So in creating this data set, we aim to explore the following challenges. So human reference tests show more lexical richness and variation than other document-grounded dialogue datasets. And that's because when we created the dataset, we took original recipes and we made them more natural in terms of how the conversation would flow, in terms of the language used, to move away from this formal language that's typically used in instructional documents. Generating from this set requires paraphrasing. The instructional responses might have been modified from the underlying document. So our team of data collectors were asked to paraphrase, were asked to add in more information and to make it more understandable for a wider audience. Common sense knowledge is required since questions might not necessarily be grounded in the document. So as I mentioned previously, common sense knowledge typically underpins dialogue, and we had to formulate new ways of extracting that and enacting scenarios where we could consider how common sense knowledge may be used. And generating requires planning based on context, as task steps need to be provided in order. So being able to follow the sequential logic of a recipe is important, but we also want to be able to move out of that structure, answer questions on different aspects of the task, and then we need to return to the appropriate section, the appropriate step in that recipe. So our motivation aims. So existing datasets for virtual language models, such as those listed here, they are very restrictive because they are intended for virtual task-based scenarios. And virtual task-based scenarios are typically very constrained, they're very controlled, unlike real-world scenarios. And that's where the task-to-dial dataset differs, because we want to include lots of adaptability, additional information, clarification, and natural conversation to really enhance how the AI interacts within a real-world scenario. So another thing we also looked at was the fact that there is a lack of consistency in instructional documents, because there are tools that are often left out of the instructions, and it is expected that the user is able to understand and how to use those tools without explicitly being told how to use them. And we get that a lot in recipes where it may say peel an apple, a real basic example, but without actually telling somebody what tool to use for that job. It could be, a fruit peeler or a potato peeler or a knife, depending on the task. And we really want to get across to the user what the most appropriate tools are for the job and what are the alternative tools that could be used for that job also. So to start with, we did a pilot study, and we wanted to emulate natural conversation between the information giver and the information follower as closely as possible. So in the first example, we had two participants over a telephone. The information giver took on the role of the chef bot, or the AI chef, and they read out each stage of a recipe, and the information follower followed that instruction and gave a response accordingly. This was then transcribed. The second experiment we did was we explored text-based dialogue. So it was using a shared document where the information giver could type out an instruction and the information follower could type a response to that. And thirdly, we tried this with one member of the team. So we had one person taking on both roles of the information giver and the information follower, and they wrote the entire dialogues assuming both of these roles. And what we found out by comparing these three methods was that the one person dialogue entry was very much similar to the previous two in terms of quality of data, in terms of natural conversational patterns, and is what that also provided us to be able to do was to produce these dialogues much faster, because we didn't have to rely on two people doing them at once. And also the cost was much higher for two people to have two members of the team working on one dialogue. So we opted to use the self-dialogue approach. So for our data sources and selection processes, what we did is we focused on three Creative Commons licensed cookie websites. and is what that allowed us to do was we were able to use those recipes, adapt them, and avoid kind of the red tape of copyright and licensing issues. And what we did for our selection process was we looked at reviews that people had left for certain recipes. So if it was a real high review and people said that they highly rated this recipe, it was easy to follow and produced results that they expected. Is what we did is we picked those recipes over ones with low feedback. So here's an example of the template that we provided to our data gatherers. And is what we did is we asked them to take the original recipe from the website, which you can see on the left in the lined box, and we asked them to reconceptualize it, focusing on how the text could be formatted into information giver format. Look at common cooking utensils and ingredients and how they could be extracted and used in our data sets. Provide full responses for modeling domain-specific intents, and recompose the original text with the practicalities of cooking scenarios with a focus on the common sense knowledge databases. So, like I said at the start, the spatial knowledge, object properties, behavioral knowledge, temporal knowledge, and contextual knowledge. And through this, we aim to capture two different types of knowledge, and that is our document level procedural context, i.e. what is the next step, and two, common sense, i.e. answering questions that are not available in the document. So our data collection methodology, we had student workers employed as research assistants on our projects, and they were employed on temporary contracts by the university. They were asked to complete a paid trial, and then their results, their dialogues were evaluated. Further advice was given how to write dialogues and format the data to ensure high quality. And all our student workers that applied to be on this study were all accepted. So we chose this method of employing student research assistants over crowdsourcing for a number of reasons. And I'm going to go through a few of those at the moment. So the annotators were given equal workloads, which were adjusted accordingly over time per annotator availability. The data collection was scheduled over 4 weeks to permit additional time for annotators to conduct work and study outside the project. Research assistants were paid an hourly wage at the university's student workers rate. The annotators were given the option to work on the project flexibly in their spare time and not commit to a specific work pattern or time schedule. Weekly updates were provided to each research assistant with targets for the week ahead and to address any issues and concerns of the task. Research assistants were given regular support by an administrator available in regular working hours to help with data entry and formatting, and research assistants had a shared forum to discuss issues and ideas with each other. And the outcome of this was that we had a really high quality set of dialogues, and there was no dialogues disregarded in post-evaluation, which is typical of things like crowdsourcing. So we have a really strong data set. And this is an example of a data set that was gathered. So at the top we have the original recipe name. We have its website address. We have the metadata above there, which is its cooking time, its servings, its ingredients. And you can see in the text itself, we have underlined the utensils that are used within that recipe. And we also have it formatted in the information giver, information follower format, which is the user and the robot. And when we evaluated our data set, we found it to be incredibly lexically rich. We compared it to the nearest data set to ours, which is the DocDial data set. The DocDial data set has a high number of documents across 4 domains. We have 1 domain and less documents, but you can see that we have a high number of turns, tokens per turns, and is what that gives us was a really wide, lexically rich, natural data set that we can generate from. So a quick overview of the API. So is what we did is we used Rasa to kind of demonstrate how we could format the data set in an API. So we took the recipe, the steps, the human responses, the ingredients, utensils, and is what we did is out of that dialogue, we looked at how these could be handled in a dialogue manager. So the recipe steps were turned into utterances. The human responses were turned into both global intents and domain-specific intents. So I'll quickly explain that. So our global intents are responses that could be used in any cooking or cleaning or task-based scenario you can imagine. So these are intents, things like, okay, what is the next step? I have done this. And the domain-specific intents are intents that are only related to the cooking task. So these are things like, I have turned the oven on, I have mixed all the ingredients in a bowl, and things like that. So our metadata for the ingredients were turned into actions along with the utensils, allowing the user to ask questions on these two specific ideas, terms. And this is a quick example of what I mean by this. So for utensil explanations, is what we did is for every utensil that was highlighted within a dialogue, we provided the user with a response through key entity extraction, so the AI could give an informative response with focus on the common sense knowledge databases, knowledge bases that I discussed earlier. So that, for example, the user could say, what is a bowl? And the AI would respond with a cooking container that is usually larger than a cup. It's kept in a kitchen cupboard. It's typically made from glass, ceramic, or plastic. And there we have tried to use as many of these common sense knowledge bases as possible. So you can see that we are comparing it for our object properties, comparing it against a similar object. It can be described as being larger than a cup. Where it is stored, which are spatial knowledge, it's kept in the kitchen cupboard, and the object properties of that is typically made from glass, ceramic, and plastic. Similarly, for our alternative ingredients, the user might say, I do not have any plain flour. And the response from the AI would be, instead you can use oat flour, bread flour, cake flour, or coconut flour. Now, there's a slightly different process and element to our alternative ingredients, that any alternative ingredient that is suggested to the user must not change the structure of the recipe. So it's okay to perhaps change plain flour for bread flour or oat flour in this scenario. But if you were to change something that would have a significant impact on the recipe, say you were changing beef for chicken, that has a completely different way that is prepared, and the cooking times and things like that change. So that was one thing we had to be aware of, and we really focused on when we created our common sense knowledge databases for the alternative ingredients. And here is an example of those dialogues generated in Rasa X. So you can see we have suggestions of using oven gloves to return the broth to the pan. We have alternative ingredients on the right. So the AI is saying, if you don't have any butter, instead you can use olive oil, ghee, Greek yogurt, avocado, pumpkin puree, or coconut oil, and ask the user if they have these ingredients. If the user says no, it does not have these ingredients, then it returns to the recipe options again, and the user can pick a different recipe that they may have all the ingredients or alternative ingredients to be able to do that recipe. So in conclusion, we introduced the task-to-dial dataset model on everyday conversations between information giver and information follower during a cooking task. We extend previous work in document-grounded dialogue systems to emulate the unpredictability of human-human conversations. We did not follow a tight sequential structure or schema as in previous virtual datasets used for virtual chatbots and AI systems. We proposed a new task-associated dataset and demonstrated how task-to-dial can be used with an API. A proposed task aims to motivate research for modern dialogue systems that address the following challenges. So firstly, we expect the AI to be able to modern dialogue systems to be able to be flexible and allow for off-script scenarios to emulate real-world phenomena. So that is one of the key factors and one of the key things that we addressed in this, and how common sense knowledge can be used to handle such off-script scenarios. As dialogue systems find different domain applications, the complexity of the dialogues may increase in structured or unstructured ways, such as documents and databases, etc. So that is about how we really look at formatting these documents and focusing on how we can still get clear instructions but model the underlying common sense knowledge to be able to add more understanding, user understanding. And that is a significant thought going forward for future data sets. So our future work, we want to benchmark and evaluate a dialogue system based on the task-to-dial data set using our ChefBot model, which is our API. Extend this approach to practical human-robot interaction in a cooking scenario, so that's using the AI system within a robot and evaluating how that functions in the real world. And identify how the approach could be used in different scenarios, in different domains such as assembly and maintenance tasks. So we have our data set available on the following, on Hugging Face and GitHub, so please feel free to go on there and have a look and for yourself and see how the data set is put together. So thank you for listening to my talk today. It's very much appreciated.